Long ago, dinosaurs ruled the Earth, but a mass extinction event potentially caused by a meteor wiped them all out. Through fossil evidence, we have been able to reveal the existence of these beasts. But what remained a mystery was the exact time they remained on Earth. For example, did you know dinosaurs existed over such a large span of time? The Tyrannosaurus and the Stegosaurus were never alive at the same time. To truly find out when dinosaurs existed, we need to know how old their fossils are, and there are two methods of doing this: relative and absolute geological age. To determine the relative age, you have to understand that fossils are preserved in layers of sedimentary rock. These are deposited in a sequence one on top of another, which means the deeper you go, the further back in time you are looking. This lets us create a relative timeline of events of when a dinosaur existed compared to another, but we don't have quantifiable accuracy. It doesn't let us say with confidence that the Tyrannosaurus is about 70 million years old. That's where the absolute geological age is required, which we can find by using radiometric dating. You've probably heard of this in the context of carbon dating developed by William Libby, for which he was awarded a Nobel Prize. These techniques rely on the properties of radioactive isotopes, which are versions of an atomic element with a different number of neutrons. This makes the atom unstable and can lead to the element releasing energy being transformed into another. For example, typically an atom of carbon has a mass of 12. This means it has 6 protons and 6 neutrons. Some forms of carbon have more neutrons, such as the second most abundant form of carbon, carbon-14. This has 2 extra neutrons and results in the element becoming far less stable. So when a living thing dies, it stops accumulating new carbon, and at the time of death it has a fixed number of carbon-14 atoms. By observing the ratio between stable carbon-12 and carbon-14, scientists are able to predict how long has passed since the organism's death. But there are 2 major issues with using carbon for finding the age of dinosaurs. Carbon-14 has a relatively short half-life when compared to the time dinosaurs walked the Earth, and it only takes 5,000 years for half of the carbon-14 atoms to decay, versus the many millions of years dinosaurs existed. Further complicating this is the fact there's actually very little carbon in the fossilized remains of these animals. So scientists turn towards heavier elements for a solution. This is where uranium-lead dating is used. It works under the same principle, except now 2 decay chains are measured instead of 1, with much longer half-lives. There are 2 forms of uranium we're interested in, 235 and 238, which by the process of alpha or beta decay produce lead-206 or 207. We just need to find a source where we can measure the ratios of uranium and lead. Instead of looking at fossils, we now look at crystals in the rock adjacent to the fossils, such as zircon. These naturally contain impurities of uranium. So by looking at how much uranium has decayed, we can find out the age of the crystal and thus estimate the age of the dinosaur fossils. And that's in a nutshell how we know how old dinosaurs are. Thanks for watching, and for more science and maths content, consider subscribing.